Okay, guys, let's see if this works for unit circle. So you've got your unit circle, and the first thing you're going to do is divide each quadrant into 3 sections. I hope I'm not off camera, I don't care. And what we're going to do is we're going to make multiple laps around the circle, and we're going to count and label as we count. So step 1 is we're going to count by halves, and that gives us our axes or our quadrantals. And we always start here. This is ground zero. This is our starting point. So if I go up here, that's 1/2, which is pi over 2. This is 2 halves, 3 halves, and 4 halves. And so 4 halves gets me back to 2 pi. So 4 halves is 2 pi. And this is 0 and 2 pi. Okay, my second lap, I'm going to count by fourths. And when I count by fourths, the fourths are the middle marks of every quadrant. But every time I make another lap, I'm going to make sure that I count my quadrantals in that lap. That keeps me on track. So if I start at ground zero and I go here, that's 1/4, 2/4, already labeled, 3/4, 4/4, which is pi, 5/4, 6/4, and 6 over 4 reduces to 3 over 2, 7/4, and 8/4. Now I'm going to count by sixths. Don't laugh at me because it's hard for me to say that word. And that's everybody else, and I'm still going to count my quadrantals as I go. So this is 1/6. This is 2/6, which is pi over 3. That's 3 over 6 up at the top, which is 1/2, so I'm still on track. So we've got 1 over 6, 2 over 6, 3 over 6, 4 over 6, which is 2 pi over 3, 5 over 6, 6 over 6, which is pi, which gets me back where I'm supposed to be. Let's see. 5 over 6, 6 over 6, 7 pi over 6, 8 pi over 6, 9 over 6, 10 over 6, which is 5 pi over 3, and 11 pi over 6, and then I finish up at 12 pi over 6, which is 2 pi. So now what we're going to do is label the coordinates. And the nice thing about the coordinates is I only have 5 options. My coordinates are either going to be 0s and 1s, root 2 over 2, or 1/2 and root 3 over 2, and the positive and negative version of that. The 0s and 1s, I'm going to go back and label my axes or my coordinates exactly in the same order. So first of all, I'm going to do my quadrantals, and think about, you're always starting at the origin and navigating out to that point in space. So the coordinates of this point are over 1 up 0, over 0 up 1, -1, 0, and 0, -1. And that's it. I don't have any more 0s and 1s to use. They're only on the X and Y axis. I've used them up. Now I'm going to do my root 2 over 2s. They always come as twins. They always pair up, and they're always on the quarter marks. So I'm going to go back around. I'm going to count on my fourths or my quarter marks, and they're always going to get some version of root 2 over 2, root 2 over 2. So here in quadrant 1, I'd go over positive root 2 over 2, up positive root 2 over 2. Here in quadrant 2, I'm going to go negative positive, negative root 2 over 2, positive root 2 over 2. Down here on my quarter mark, negative root 2 over 2, negative root 2 over 2, and 7 pi over 4, positive, negative. Because we're just moseying around in the xy axis. So now that leaves me all of my sixtheses, and they're going to be some version of a 1/2 and a root 3 over 2. And I remember when I was in high school, this was driving me crazy because I never could remember which one came first. And then I went, hold on. Let's think about this. 1/2, if you put it in a calculator, 1 divided by 2 is 0.5. And root 3 over 2, if you put it in a calculator, is about 0.866. So this number, root 3 over 2, is a little bit bigger than 1/2. So if I just look at quadrant 1, and I'm comparing this point to that point, that's pi over 6, that's pi over 3. If we had 2 mice that started at the origin, and I said, okay, I want one of you mouses to run to point A and the other one to get to point B. A mouse has to run a lot and jump a little. B mouse runs a little and jumps a lot. So that means that the pi over 6 coordinate is going to have the bigger x number. The bigger number is the x coordinate, and the smaller number is the y coordinate because he just has to hop up a little bit. So pi over 6 is run a lot, root 3 over 2, jump a little, 1/2. Pi over 3 is run a little, 1/2, jump a lot, root 3 over 2. And then if we think about 2 pi thirds, we're doing the same activity, we're just going in a different quadrant. So we're going to run a little in the negative x direction, jump a lot, positive y. So negative 1/2, positive root 3 over 2. And 5 pi over 6 is run a lot negative. So negative root 3 over 2, jump a little, positive, 1/2. And you can go finish out the circle that way. And the nice thing about the unit circle is every single one of these coordinates has an x and a y component. And x and y are in alphabetical order. Well, the cosine and the sine, that's in alphabetical order. And in the unit circle, the cosine is the x coordinate and the sine is the y coordinate. So the cosine of pi over 6 is root 3 over 2. The sine of 11 pi over 6, that's run a lot, jump a little down, that's going to be negative 1/2. The cosine of 3 pi over 2, 0. So if you guys will sit down and try to reconstruct this and see if you can time it so you get this whole thing reconstructed in under 2 minutes, then you walk into your test, you sketch it out, you do 6 laps of the circle. Highest thing you have to do is count to 12, run a lot, jump a little, and then you don't have to think about the unit circle anymore. Hope this comes through. Bye.